Hopefully that's working. I have an idea for your test. I want your opinion on it. It's very important that the important thing about the first test is that it sets the tone for all the rest of the tests. It's not as important to me that you do well on it. I figure you'll just figure out how to do well. You'll do the test, you'll see it, and then you'll do better on the next test. Okay, I know you all want to do well in the first test, but honestly, the next test is worth more. Hold on, that's the live stream thing. Okay, so I want the test to be like an interview. I want all the tests to be like an interview for that matter. Um, which means um I want to do it differently. Um, than I've done it before. I mean, I've done these tests where they're speaking, but the problem is that people take too long. I haven't incorporated any sort of grading into people who take too long to answer a question. If I ask what is math, I want you to answer it fairly quickly. But if you sit there for 5 minutes and can't answer it, I just it doesn't make me feel good. So I'm creating a new rubric basically, and I'm having the test so that you basically just speak to answer it like you're on it, like you're being asked. I want to do that with a lot of the questions. So the only questions that won't be that way will be the ones we have to solve a problem. You have to open up Zoom and put a problem in, but that's only 20% of the test. The rest of the test, I want you to talk. And I think I told you in class that I want to make it a time thing, but I'm it's not that I'm encouraging cheating, but I think it's fair that everyone know the rules when we get started. I if you're going to take this test like an interview and it's going to be a Zoom interview, people have notes when they take Zoom interviews. I don't want you to have notes when you do Zoom interviews, but I'm considering letting you have notes, but not allowing you to use them. So that means it means this is an interview. And I don't want to see any notes. I don't want to see any dawdling. I don't want to hear any rustling of papers or anything like that. So you need to be able to convey. If I see it, I take off points. But I'm not going to take off point. And I want you to answer the questions as quickly as possible. But if you can do it without me knowing that you're doing it, I'm feeling like maybe I'll just let that go. So if you have if you can whatever it is that you have to do to if you need something to jog your memory, but you can't be picking up papers and rustling them because if they did that during an interview, you wouldn't get that job. So I'm going to grade you like it's a job, and you're going to do the best you can to answer my questions as quickly as possible and as correctly as possible. So you'll be graded on how quickly you answer the question and how correct the question is. But I'm not going to make you I think I'm just gonna. I think if you need to have notes or something, if I have three monitors here, so if you have another monitor, without looking too much to one side or whatever, if you have stuff, you need stuff. I'm thinking about letting that exist because I don't think it's fair that some people are cheating and then you aren't. So then they have these notes or whatever, and I have no way of knowing that they have to note. I mean, cheating has gotten very bad lately. And all I want you to do is have the experience of an interview. I mean, I think that's the more important thing is answer the questions. And the questions I ask are, when I ask what is math, I want them to be answered quickly. I don't want them to be answered slowly. I kind of hope that this is sort of part of your future, that your kids are going to ask you someday, what is math? And if you take 20 minutes to answer, say, well, it's derivatives and integrals, well, you're going to lose them. So I want you to have the answers sort of quick. I want that to be part of those vocabulary words. And by the way, I'm probably the only math teacher that makes you know these things. All my friends are like, I don't know what math is. I'm like, yeah. And what good did it do? Y'all hate math. So anyway, this is math, I want you to, so those for vocabulary questions, I want you to be able to answer as quickly as possible. And I'm going to listen to them. So that's another reason that I have to be quick because I will be listening to them and you're going to make me stay up all night grading papers if you take too long to answer them. But I really think some people are getting help answering those questions. It seemed to me that the people who were answering those questions were getting other people to answer. If they took a long time, other people were answering the questions. Like they were doing the whole thing where they take a picture of it and they wait for the answer and I don't want to do I want to penalize that. I want you to answer as quickly as possible. And if you answer nicely, quickly without, I don't know that you have, a handful of notes here or there, it's not going to bother me. But it would bother me on an interview if you rustled too many papers. So that's my motive. What do you think?
Question. Sorry.
What's Suave? Go ahead.
So for the speaking part and like the notes part, you're talking about like we can only have those like notes for the speaking portion, right?
No, I'm thinking you can have notes. Here's my problem. You can have, I think you should be able to have notes for the whole thing. I just don't want to see them. I don't want to see them. I don't want to hear them. I don't want to know they exist. If I see or hear or know they exist, you're going to lose points. Okay. But you can
Okay.
have, but if you have them on a room scan, if there's a room scan, they're going to, I can't turn the room scan off of honor lock. So they're going to make you scan the room. But if I see papers, normally I chastise people for having papers. I'm not going to do any of that. But but you best not move papers. I don't want you to see papers. I want to hear them. Okay. I want
Okay.
just think about, just do your best. I'm not grading you on how you're dressing or how your clothing is, but think of it as an interview. You're going on an interview, you're being asked questions. And that's the way I want it to be. So I don't want anything that takes away from that anytime if you're looking away or getting help from somebody else, all that stuff would be bad on an interview. So convince me that you know your stuff and the faster you answer the question the better. So
Okay. So
okay,
how would we answer the question? Sorry, I've never taken a test like
this
from
one.
like I haven't taken a test from like on honor lock and stuff, so I don't know how like the format works and stuff. So
Well, honor
is it
lock.
like
So honor lock won't let you don't think you're going to be able to split the screen because you won't be able to do that. But if you had another
yeah,
screen, you could do that, or if you had paper, you could do that. But you can't have honor lock on half the screen and then your notes on another half. So that's not going to work. Um,
okay.
So
I
Honor
was
Lock
just saying,
will lock down the browser and everything. Although I will
yeah.
tell you, Suave, honestly, some students have figured out how to split the screen and trick Honor Lock, and that's part of my problem. Because there are some who will know how to break Honor Lock. And then again, that's not fair for those of you who don't know how to break Honor Lock. So I'm giving you some other way to, if you have a piece of paper. The other thing that happened was I believe that people were just giving me answers from questions. So the questions are very similar to quiz questions, and sometimes they were the exact questions. So now I've had to go in and change the questions so they're not exact anymore. So because they would just write the answer down and I'd have to take off points because I was like, how did you get this answer? You didn't weren't allowed to have paper. You didn't open up Desmos once, and then magically you got an answer with 6 decimal places. I'm like, you didn't do that. Someone else did it for you. And I never accused anybody of cheating, but it really, if I were giving an interview and I was asking you how to do something and you just magically came up with an answer, I would be very unhappy. Be like, how did you do that? But I'm not there. Honor Lock is recording you. So I'm not there to give you that feedback. But I do after the test. I say, what the heck? And I take off points. I mean, the answer might have been 6 decimal places and you might have gotten it right. But if I don't see how you did it, it doesn't mean anything to me. Okay, those are the questions that you don't say anything. You just have to show the work on Desmos. Okay, so, okay. Any questions on that? It's going to be, I hope it works. If it doesn't, I've been giving the test where they're speaking. That I'm okay with. It's just a little different. It's all going to be different. So you all can give me your feedback at any point. And the first test is, this will be the first of test that I'm going to do this way. If it's a complete disaster, then I'll just go back for the midterm and final. But I really want all the tests to be the same. The first test is really just to help you get ready for the midterm. Okay. You don't know what I'm going to ask. You don't know how I'm going to ask it. You think you do, but you don't. So you have to see it. Do you know what I'm saying? Like, you have to see the test. You never trust teachers. They always say, not, I can talk all I want about how I'm going to do this, that, or the other thing, but it really matters what actually happens and what they do. And so this first test, I will use as my model for the rest of them, but you should too. I mean, you wait till you see it. But if it doesn't work out, if you don't like some things about it, then let me know. Okay. I just want to make I'm just this technology is making cheating so easy, and I don't want you to be at a disadvantage if you're not cheating. So I'm thinking about, as I said, letting you have your notes and stuff. But again, if you the cheating that I saw last year took a long time. So that's why you have to answer quickly. So if you're a good student, you know your stuff and you can answer quickly, that would be great. You don't need your notes, that's even better. But if you need something to, glance at or something, just that would be the key here is to answer probably the answer as quickly as possible. And I know some of you are slow. I'm not particularly fast. I read very slowly. So we'll deal with that. If it turns out to be a real problem with you, then you can let me know. But as long as I feel like you're on an interview answering the questions sincerely and to the best of your ability, that will be fine. Okay, and I told you about the exam. It's 15 questions. That's not going to change. Three of each type. Midterm is four of each type, more or less. So finals, five of each type, more or less. Okay. Anything else you want to know about them? None of the material that I'm covering today is on none of the new material from Mod 5 is on this derivatives test. Okay, it's only 1 through 4. So let's go over 4 and see how you did with quiz 4. Okay. Let me get rid of that. Is there any notes? So quiz 4 was on implicit differentiation, hyperbolics, Newton's method, acceleration, and higher order derivatives. Okay. Where did my notes? Where did my thing go? Is this it? Oh yeah, here it is. Mod 5. Oh, there's still 2 mod 4s. Okay. All right. No, it's mod 4 that I'm in. Where was the quiz? In this one here? There it is. Quiz 4. 7. 2 people are missing. Um, quiz 4. Okay. Oh, look at that. Make it bigger. Say the following. So on these questions on the test, you're just going to have to read them as you see them. So you won't have time to um, just like reading out loud. So anyone want to try this one? Tell me what it says. Only one person missed it. It must not be that hard. Anyone? Go ahead, Christian.
Okay. Um, derivative of sinh times
Sinh.
the inner function of
Not
cot equals cot times the inner function of cot times sinh uh, times the function of x.
what did you say for the last
G
one?
sinh of x.
Yeah, so that should be your clue something's wrong. Because you've been saying times for all of these, and then there's an actual times. So
Okay.
when you say this, you're saying it's a derivative of sinh of cosh of x equals the cosh of x times sinh of x. Plus, what's the last one there, Christian?
G plus g to the power times 0.
Okay, everyone says that and it's wrong. When the 4 is in parentheses, what does that mean? Not to the 4th power, it means the 4th derivative. Ah. And then the 0 means evaluated at 0. So let's see. The derivative of the sinh of cosh of x is the cosh of x times the sinh plus the 4th derivative of g evaluated at 0. Okay. Now this is a multiple choice one, but on the test, you just have to say that as best you can. The part that people mess up the most is that 4th derivative one. That at the end is what gets people the most. The sinh of cosh, yeah, maybe not. And of course, you could always say hyperbolic sine, hyperbolic cosine, but this when there's multiple choice like this, you have to pick the one that's there. Okay. Thanks, Christian, for volunteering.
Welcome. Thank you.
Newton's method. Anyone want to tell me what to do for Newton's method? I'll click on the formula sheet. I got that much. How do I find this to 6 decimal places? This is one of those questions that will very likely be in the calculate thing. Ah, Nana's here. Okay. So how do I calculate, use Newton's method? I got my decimals from your state. I want to solve this to 6 decimal places. So let me copy and paste it here. I see that 3 sank, so I'll just raise it to the 3rd power. Okay, so oh, well, there's the answer. It's right there. So I know the answer is something like minus 3.14, maybe 4 something. I can zoom in, but I'm not going to get credit for that. I have to use Newton's method. So where is Newton's method in the formula sheet? Does anyone see Newton's method here? Where's the formula?
Isn't it the first one?
It is the first one. Okay, so oops. So let me go down. So I'm going to close the formula sheet now that I've copied it, and I'll just paste it here. Okay, so I decided that it was easier for me to make a function out of Newton's method, so I don't have to do it each time. I don't have to go through a step at a time. And then set this equal to f of x. So I have f of x equals this. Okay, equals. So I still see the zeros right there. Now I can see it to 5 decimal places. Minus, so that's 5 decimal places right there. I only need 1 decimal place more. So if I put that into z of that, I got all those decimal places. Am I done? Is that enough? Should I just use these 6 decimal places? 1, 2, 3, 4, 5, 6. Maybe I should try it one more time. So to do that, I just take this answer and I could put it in z again. Z of that answer. Do you see how that's not changing? That means I'm done. All those decimal places are all good. So now I can just go back to the problem and type it in. Well, let's see, that's it, 2, 4, 6, all the way to 3. Okay. So I would stop. I only need that. That's 6 decimal places. Okay. But to get credit for this problem on the test, you will have to open up your decimals. You'll have to somehow do Newton's method, and then you'll have to plug in your guess. And as I said, I got a really good guess here, but it didn't have to be a good guess. I might have just had to do it a few times. Don't be fooled by that's, uh-oh. So that's the function and that's the 0. But when you make that z, like I make this z of x to do Newton's method, gives me that weird graph. You just have to ignore that graph because you don't need it. Okay. Any questions on that? Mostly people get that question. Again, mostly people get it. Okay. Okay, so for this question, it says, say your prediction. Okay, and it actually, I give you words here, but for the test, I may not give you words. Okay, so they're just asking you to say stuff about the 60th week. Okay, so I'm going to click on this. I'm going to go to my table and I'm going to put in the 60th week. Okay, and now I can read from here. I can say, according to the, okay, this is a sine regression. So according to the sine regression, the 60th week, what is this? Height in centimeters. Okay, so when the plants are 60 centimeters tall, sunflowers are 60 centimeters tall, they are, oh wait, not 60 weeks. Oh, time is in weeks, and then the height is there. Okay, so 60 centimeter, 60 weeks, they are, looks like 0.97 centimeters tall, and they're growing at a rate of 9.9 centimeters per week, and they're accelerating by 9.67 centimeters per week. Okay, so that's what I'd like to hear you say. So, oh, give it
So
answers, whole
for
answer.
A though, where it's asking, it's with a period of A.
Oh yeah.
I couldn't get that one.
Okay, so here's the period. So
I didn't
this the
understand what it was
only way to
asking.
get the period is to do it this way. Sorry. It is a sine regression with a period. So you have to look, you have to see when it, see that point right there? That's at 0. Okay, the next time it's at that point is right here. So it took 20 weeks for it to go there. This number here is wrong. Okay, 10 is
Okay,
not
okay.
the period. But
I put
I
20
just got,
weeks and I got it wrong.
you got it wrong? Did you write
Yeah,
20 weeks or did you write? So the answer is just
I could have put
20.
something. Oh,
If you write weeks, for this one, you don't write any of the units because so A, B, they all have the units written after them. Do you see that? So in this one, the quiz, when you're answering it, you have to type in just 20.
okay.
Okay. What is the 10? B. So that's B, A, C, D. Okay, so A is 20. B is 10. C is 1. And then D is 10. Okay. I don't know why they can't do them in order. That's just weird. But all right. Any questions on that? So I'm very interested in you reading this. I mean, this question will stay the same, but you're gonna have to say that. I mean, this here is just there to help you say what you need to say. Okay. All right. But to get the period, you have to look at the graph, I think. This is the numbers because it's misleading. I can't change that number. If I put a 4 in there, it changes yeah, see what it does? It changes my answers. Because it's in the formula. So the best way to do it without changing that is to just look at the graph. All right. Got that. Got that. Those are some good questions so far. Okay, what happened in lines 5 and 6? So, oh, so there's a typo here, this question. Then that might be that might be why you're misled, Christian, because that 4 reads to the 4th power, and ain't no way that's to the 4th power. If that's g of x, and then they had g to the fourth power is 120, that's fantasy. Because that doesn't happen. That's not, there's no way g to the fourth is equal to that. Well, unless they're solving an equation, they could. But that 4 should be written this way. It should be in parentheses. Okay. In which case it would be the what? What does that mean, Christian? You just knew this. I just asked you this. What does it mean when the 4 is in parentheses?
It would be the derivative.
The fourth derivative, right? So take the derivative 4 times. It's definitely not Newton's method. So, all right. I think I'm done. This is the sunflower problem. After this is not difficult because 75% of people did it. Got it right. Okay. Any questions on this quiz? So I didn't see any vocabulary words in here wrong, so they must have been okay. There was one say the, and I told you that that's when they ask you to do the fourth derivative, that's going to be a problem. This one, that one that I did from the last one I just did, which is what's happening here, that shouldn't be a problem. And the calculation that I asked on this was Newton's method. But there might be other ones that this particular, hold on. This particular thing, I can tell you right now, implicit differentiation, there is one implicit differentiation problem that has to do with an ellipse. That one from the homework, I might ask you. That's the only one I'm going to ask you. I'm not going to ask you any of those other hard implicit differentiations. Hyperbolics, the hyperbolic question is usually the derivative of like hyperbolic sine squared or something. Newton's method you saw. Acceleration higher order derivatives. I could easily ask you, I could give you the position function and say find the derivative. If you'd be so lucky if I gave you that question. Find the acceleration at some point, because you just plug it in. There's nothing to do if it's except to know that you're taking the second derivative. Okay. And then as far as the discussions go, I'm only asking you 3 discussion questions. So one of them's going to be a limit, one of them's going to be a derivative, and one of them's probably going to be an average rate of change. Okay. And yeah, I only have 3. The derivative could be with the sign in it, or it could be without the sign. Okay, but the stuff that we're doing that's due today is the mean value theorem. Oh, what happened to the mean value theorem? That's due next time. That could also be, you could be asked the mean value theorem, but I think that was from the last, that's not going to be a discussion question because it's from the last, that we haven't gotten to that yet. That's due next week. Okay. So even though we did mean value theorem and it could be on the quiz, it won't be on, or it could be on the test. It won't be on the test as a one of these. Like it won't be like a discussion problem, presentation problem. Okay. Let's take a look at the discussion problems. So, oops, hold on. I keep closing the window, so I'm supposed to be opening them. This one. Okay. So the discussions lesson. Mod 5. Discussion. Oh, that's due mod 5. So that's mod 5 once. We'll work on it today, but it's not due until next week. All right. Trans. All right. Davon, are you here, Davon? Did you finally show up? Yeah, he's here. He's been here the whole time. Okay, Javon, what was yours about? Studying? Okay. Sarah says that Nina, are you gonna, let's see, Nina's the speaker for them, so let's see what she said. Did everyone hear that? Could you guys hear that? Please let me know because I heard it through my computer and not through my headset. So I feel like I have to change some setting.
I didn't hear, Professor.
All right, so why is it playing?
I did not hear.
Yeah, so it played it for me, but it played it here. Why doesn't it play it there? Um, hmm. Well, it may be a bug with the. Can you hear it now? Wait,
10 hours of studying, you will have 60%, an increase of 5% per hour, accelerating 0.2% per hour.
was that better?
Yes, 85.
Yeah, we heard it.
Okay, good. I don't, this, I have to find out why that's a problem. That shouldn't do that, but okay. And then I did this one too. Let's see what this one says.
12 equals 70.5%. 2 to the power of 12 equals 4.75% per hour studied. C double power of 12 equals negative 0.224%.
Great, super. All right, I'm not going to play the last one, but I assume she did this one. Very good. Any questions on this? Wow, Nina, you did 4 of them. Okay. Anyway, these look good. You said what you had to say. The only thing is that was this a period of 60? Sarah said was a period of 60.
Yeah, it was. It didn't show up on the graph as that, but then you told us to make it to put
Right.
it in as a note. Then it was a
So
period of 60.
Melanie, you have to add to yours, you have to add with a period of 60. Okay. Nobody else has to do it, but Melanie has to say with a period. Do you get that, Melanie? You here? I saw you. You've been here the whole time. Yes? Are we good? All right. How about the other group? Tara. Melanie, that was you saying, okay, you're going to fix that?
Yeah, I'm gonna fix it.
Excellent. Tara, what was your period? So if I look at her period, it's like looks like 400. Just looking at this graph, it looks like it takes 400 to repeat. Okay. Uh, hey. I don't have any audio. Anybody? Mahir, you're here. You want to read what you wrote?
According to the sine regression, with a period over of 400 at 100K, you will have 2 BFFs. No change in BFFs per $1,000, not accelerating or accelerating.
Okay, one of those is decelerating, not accelerating or decelerating.
Oh, yeah, sorry.
I'm sorry, not accelerating or accelerating. Yes, it's not. In other words, it's mostly at whatever it is, 100,000, which is, I think, right here. It's a very straight line at 100,000. Oh no, where's 100,000? Should be where that dot is, right? It looks. Oh, so here's the thing about graphs and numbers and stuff, when you start using real life stuff, if I look at 100,000, it looks like it's going down and actually it's accelerating. Okay, it looks that way. But here's what gives me, this is where you start learning about life. These right here are 100, this is 200, 400. Thank God you don't have 200,000 and 400,000. But these blocks here are, each one of them is 50 wide. How tall are they? So they're 50 wide, but how tall are they? Anyone? Kara, how tall are these boxes? This is your graph. You made it. Do you see what I'm talking about? The axes, how are they labeled? I'll even go into your thing because you're, look at this.
It's person per box. It's
Each
not very high.
Right, each box, each of these little boxes, actually, this is even worse. Look at this. Each one of these boxes is only a half. Okay, so right here at this 100,000, it's maybe changing by a little, like a quarter of a box, but that's a quarter of that's a quarter of a best friend over, and these are changing by, this is 50,000, 100,000. These are changing by 10,000. So you have a half over 10,000. So do you see why that's small and turns out to be kind of nothing? It's going, you're losing hardly any best friends. And it's not accelerating or decelerating because it's just such a small number, but it's actually accelerating. It's just a very small number. Okay, that's what you have here. See, didn't I tell you this right here not to type 8.2 times 10 to the negative 4? That's 0.00. That is 0.000. How do I say it? Let me put it here. 0.000824. How many best friends is that? That's such a tiny number, it's virtually none. And same with this one here, 0.001 is 1/100th of a best friend. That's not even, you'd have to make $100,000 more to pick up a best friend. So that's kind of nothing. Okay. Does everyone understand that? Thank you for attaching that to the, oh, and you touched it the right way. Okay, so these are fine. Okay. Do you have other people in your group? Is it just the three of you? These groups are lopsided. The other group has all these people in it, and you only have 3 people. Okay. All right, I don't need that. What's next on our list? Oh, the class questions. All right, I don't need that. I need, no, I don't need that one. Hold on. Okay, class questions. Okay, Suhave. Okay, first of all, let me just ask the general question. I can tell you I'll tell you more about the test. The first vocabulary, there's 3 vocabulary questions. I try to split them up. So the first one is really easy, like what is math, what is calculus, so it's a pool of questions. So you won't get the same question as somebody else. You'll get one of those questions. But the first one is usually very easy. Okay, what is math? What is calculus? How many points do you need for average rate of change or something like that? Those are really pretty easy questions. Most people get them. Later on, you could see harder questions. So when I ask what is math, math is make sure you unmute yourself because I'm going to ask you these questions when I get to you. You know how to unmute yourself quickly? Those of you who aren't familiar with Zoom, I think you could just hit the space bar and it mutes and unmutes you. I'm not sure. That's what students have told me in the past. Okay, so The question I ask is, I'll start off and then I'm going to get to Suhave. And if you want to look and see which question you have, hold on. So you can think about it before I get to you. Okay. I'm going to add, I'm going to say math is a language. Calculus is the study of change, what's changing or functions. The rate of change, the average rate of change requires 2 points, the slope of the secant line. The instantaneous rate of change, when you take those 2 points into 1 point, so only need 1 point for instantaneous rate of change. And that's also called the derivative. It's called the velocity. It's called dy dx. It has all those names, but it's the instantaneous rate of change. Okay, so now, what is the derivative of a constant, Suhave?
0.
It's 0. Okay. Nyla, what's the derivative of e to the x and natural log of x?
The derivative of e to the x with respect to x is ex. E
E to
is
the x.
yes,
E,
e to the
to the x.
and the derivative of ln x with respect to x is 1 over x.
Correct. Very good. Sarah, what's the derivative of sine, cosine, and tangent? Sarah?
Yeah. The derivative of sine is cosine, and the derivative of cosine is negative sine. And then the derivative of tan is secant squared.
Very good. Jacob, what does the chain rule say?
You find the derivative of the outside, you leave the inside alone, and then you multiply the derivative by the inside.
You multiply that by the derivative of the inside. Yes. Very good. So when you're thinking chain rule, you're thinking insides and outsides. Okay, good. Devon, what's the relationship between position, velocity, and acceleration? Devon?
Sorry, Professor. I'm driving home right now.
Oh, can you tell me what the relationship is? Position, velocity, acceleration? The velocity is another word for the derivative.
Derivative.
Right, and acceleration is what? Not the first derivative, but
Second derivative.
thank you. You can go back to driving now. Kara, what does the mean value theorem say?
It says a derivative exists on a b, so that is equal to the average rate of change.
On AB. So that's an interval AB. The derivative on that interval. There's a derivative on that interval that's the same as the average rate of change on that interval. Okay, Mahir, say that question and then answer it.
What is the sine? What is the derivative of sine h and cos h? Right?
Yeah, no. You're the only one I wanted to say the question because it's not said that way.
Cos,
Yes, and
sine h,
no,
sin,
not cinch. Like there's a C in there.
Oh, okay, cinch.
Like it'll do in a cinch or something. Yeah. So what's the derivative of cinch?
Sine x.
No. What's the
What?
derivative of cinch?
The derivative of cinch is
What's the
cos.
it is cosh. And here's the tricky one. What's the derivative of cosh?
Cinch, right?
That's it.
No.
Not so tricky. It's only tricky because you put a minus sign in there because the derivative of sine is cosine. The derivative of cosine is minus the sine. That's not true with cinch and cosh.
Oh, okay.
They're similar, but not the same.
Mhm.
Okay, Nena. What would you do if you wanted to find the derivative and the function is in an equation but not explicit? So it's not explicit. What type of differentiation would you use, Nana? Okay. Can you hear me? You're still muted.
Sorry, implicit.
That's it. Exactly. Remember, that implicit differentiation is just taking the derivative of the equations. Okay. Anusha. Anusha's not here. But Melanie is. Melanie, do you know what Newton's method does? Where's Anusha, though? She's out. She's usually here, isn't she? Okay, Melanie, do you know what you could answer your question? What is acceleration?
The second derivative.
There we go. Do you know what Newton's method does? That's the one that I did at the beginning. It's used to solve for. Oh, there's Anusha. Anusha. I just walked.
Hi.
Anusha, what does Newton's method do?
I'm not sure.
Can you? Newton's method is used to find something. It's a method, so it's used
on the roots.
to find the roots. Sure. What's another word for roots? It's with a Z.
The zeros.
Thank you. Okay, good. All right, now let's see. All right. So now I get to start talking about the topics that we're supposed to do today in Mod 5. Are there any questions? So that's all the end of Mod 4. We looked at the quiz questions, we went over all that stuff, and we're done with Mod 4. Okay, so what do we have in Mod 5? We have a few things. We have local linear approximations, related rates, inverse trig functions, differentials, and error. That's what we have to do this week. Okay. All right. The speaking out stuff doesn't seem to have any of that in it. Why is that? Hold on. Oops. If you don't have the speaking out stuff here, why is it missing? Hold on. I copied over from the other class. Okay, so the say out loud stuff. So what we're going to be saying, we'll be working on this week, and what you're going to have to know how to say is inverse functions. So when you raise something like sine to the negative first power, that's the inverse sign, which you should know from pre-calculus. So this is, when taking the derivative of it, you'd be saying the derivative of the inverse sine, derivative of the inverse tangent, derivative of the inverse cosecant. Sometimes they are said as arc cosecant. Okay, and that one right there, this guy here would be the derivative of the arc cosecant of the inverse function of f. Okay, so that's not f of x, that's the inverse of f of x. Okay, and you could also have quantities and stuff in there. So, all right, and you can also evaluate. You can take the derivative of the inverse sign. So these things would not be on your test coming up, but they might be on the midterm. Okay, that's Mod 5 stuff. Okay, so now let me, the discussion that you're going to work on today is the mean value theorem. So I'll go over that when we do that, but let me talk to you about, hold on, let me get back to Mod 0. Mod 0. Okay, so the first thing I want to talk about are these two, local linear and related rates. Okay, so it's also, local linear is also called linearization. And what it is, the basic idea between linearization and so on, this is all review. So we went over these questions, velocity derivative. So what is local linear approximation? So what you're doing is you're taking a function and you're creating a line out of it. Just like, like that last group I said that it wasn't accelerating or decelerating. The BFFs, Mahir, I think that was your group. Remember I said it was basically a straight line? Well, if it's a straight line, why can't we just make a straight line out of it? Like, why do we have to have a curve at all? We can have a straight line. So what we do in local linear approximation is we create a straight line out of a function. Okay. So if you're looking for something like the square root of 12, you don't know what the square root of 12 is, but you know what the square root of 9 is. So you could create a tangent line at 9, and then you could just assume that the square root kind of looks like a line. So let's take a look at that problem. So here's the square root on the calculator. Here's the square root function's little curvy thing. And you see that blue line? That's just the tangent line at 9. Okay. So here's some calculus for all of that. But just want you to show that if we have the equation of that line, then we could figure out, instead of trying to figure out what the square root of 10 is or the square root of 11 is, we could just plug 11 and 12 into that line and get the same answer. So let me do that on Desmos because I'm not loving Desmos. Okay, so what I'm saying is, suppose I have a function and it's the square root of x. Okay, and what I want to find is I want to find the square root of, I want to find square root of 12. Okay, so I'm going to find the center, which is near, and something we can get the square root of, which we can find the square root of 9. Okay, so then I'm going to do a tangent line at 9. At 9. Okay, so what does that look like? Well, if you remember, a tangent line looks like the derivative at some point times x minus that point plus the function at that point. Okay. So I'm going to use 9. So 9, 9, 9.
Are we supposed to be able to see your screen?
You are supposed to be able to see my screen. Are you not seeing it? How about now? Can you see it now?
No.
Really? I'm sharing screen 1. It says I'm sharing screen 1.
Okay, I can see.
Thank you for letting me know that. I don't. It says I was sharing screen 1. I don't know why it
I was
wasn't
on the
sharing.
wrong tab. That was on me.
Oh
Sorry.
yeah. The Zoom has tabs now. Sorry about that.
Yeah.
Okay. I made that mistake too. All right. So f of x equals the square root of x. Here's the local. Do you see the tangent line? Do you see how the red line and the black line look similar around 9? In fact, they're exactly the same at 9, but anywhere near there, it's hard to distinguish them. Okay. So let me create a table, and I'm just gonna put in, I'll put some x values in one side, and for the other side, I'm gonna put in f of x, and then I'm gonna do L of x. Okay, so if I plug 9 into both of those, I get 3. If I plug 16 into them, well, the square root of 16 is 4, but I get a different number because at 16, see, they've started to separate. This one gives me 4, that one gives me the bigger number. So let's not do 16, but let's let's look at the other numbers. Let's look at 10. They're very similar at 10. Like I can't even, at 10, I can't tell them apart. They're right on top of each other. They're off by thousandths. Okay, what about 11? At 11, you see they're starting to separate. Does everyone see that? They're starting to separate. This one right here is the actual answer, and that's up there is the local linear approximation. Local, because it's nearby the number 9, like the local train. And approximation, because it's not giving you the same answer, but it's pretty close. We're off by 200ths. Okay? And the next one is 12. Okay, so our approximation is at 3.5, and the exact one is 3.464. So we're off by 400ths. Okay? Does everyone see that? That's what local linear approximation is for. And all it is an application of derivatives. It's just finding the tangent line. I love this question. Okay. If I wanted, let me just do this. Well, suppose I want the square root of 122. Well, I wouldn't use the center of 9. What center would I use? What's close to the square root? What's close to 122 that you can take the square root of? 120 what? The square root of 121 is 11. Okay? Yes? So now instead of 9s, I'll put in 11s. Okay, and if I want the square root of 121, okay, let me hit enter. I'm getting very different answer here. Why am I getting 11 and 20? That's not right. The derivative at 11, x minus, oh, 121, sorry, my bad. That's why it's so far off. There we go. Now they're exactly the same at 121. 122, they're really, really close. Because again, if you go back and you look at 122, they're virtually the same. Okay? In fact, the further you get out, this square root function looks very much like a line the further you get out. What if you try to take the square root of 0? What's the square root of 0? Square root of 0 is 0, but if you use the local linear, you get 5.5 because here's 0 and there's 5.5. They're not, the local linear is, you're not local to 121. This only works when you're local to the numbers that they say. Okay. Let me show you another one that I've seen in chemistry. The sine of x. And we want to find the sine of x with small concentrations. So you want the sine of x when x is small. So near 0. Okay. All right. So there's the sine of x near 0. Let's take it home. Turn these off. Okay, so the center is this. So you want the sine of 0. So the center you're going to use is just x equals 0. That's, or a equals 0. Write it that way. That's the center you're going to use. So you want the tangent line at 0. What does it look like? Do you see a tangent line here? I see a tangent line. Because I'm unable to, anyway, this, if I put a line here, it looks like a line that goes up 2 over 2, up 2 over 2, like 1. Oh no, up 2 over 2, would that be up 1 over 1 would be like a slope of 1. Anyway, so if I want the derivative of that function at 0, I get that that's 1. So that's the slope there. So the derivative of 0 is just going to be 1. Okay. And then you're going to have x minus 0. And then you have f of 0. Okay. I don't want 121. I see these numbers are way off, but if I pick numbers near 0, can you give me a number that's near 0? That's not 0. Anybody, I'll take any.
0.015.
0.015. There you go. See, my local linear says 0.015. My function is actually 0.0149999. It's virtually the same. Okay. All right. So what if I want to, instead of writing it this way, what if I want to actually write what it is? So I have the L of x equals, I know that the derivative is 1, that I'm doing x minus 0. And then what's the sign of 0? What is f of 0? F of 0? That's just 0. So all of that right there, you see, there it is. There's the tangent line. Very nice. Okay, but that's another way of just saying that's just equal to x. Okay. So what does this mean? So this is used in chemistry because they have like concentrations that are really small and they don't want to deal with the sign of x. So instead of using the sign of x, so this would be the sign of x. They're just going to use that. They're just going to use x, just x. Oops, it doesn't like that, does it? Huh. There we go. 1x plus 0. Okay, so you'll notice that any number you give me, that's small. Okay, do you see how close it is to the actual value? Because it's on that line. And when you're around 0, it's the same. Okay, so you could basically throw out the word sign. Anytime you can throw out a transcendental function, it's great. So we're not throwing out the word sign, we're throwing out the word sign when we're talking about small numbers. And in chemistry, when they're doing concentrations, they're small numbers. Okay, chemicals aren't usually very concentrated. So you can almost always throw them away. Okay. So there I showed you sort of 2 examples. One is actually finding the square root of a number, which is very popular on exams. And then the other one is just, here's the chemistry example where they just, instead, if you want the sign of 0.001, you just use 0.001. Let me tell you about chemists. They hate doing math. And so having the sign of a small number, just be able to throw it out, they love that. Okay. And here's some decimals and stuff. There's a question. All right. There are harder ones that I'm not thrilled about. Like use a local linear approximation to find the quantity of, let me just tell you, so this is a ridiculous question, the 7/3. You have to find out what 7/3 is close to in terms of pi. Now, why do you have to do that? Why do I need to do that? Well, you see for the sine one, we picked 0. But remember the other ones where I said, why did we have to, so look, why did I have to pick, when I did the square root of 9, let me go back to that. I wish I hadn't deleted it all, but let me just, g of x equals square root of x. Okay, turn these off. Okay. Why did I have to take a center? If I want the square root, I want the square root of, that's the wrong spot. Let me just say, I'm looking for the square root of 12. Remember this, square root of 12. And there's the answer. Calculator will just give it to us. Okay. So why did we have to do the whole, why did we have to pick a number near 12? Well, the reason why we have to do that is because g of x is equal to g of x is equal to x raised to the 1/2 power. Okay. And the derivative g prime of x is equal to 1 divided by 2 square roots of x, like that. Okay, and in that local linear approximation, when I said L of x equals, and I said the derivative of a times x minus a plus the function of a. Okay, and then if I plug the number 12 in there, basically, or that's 12, let's just put this here for the derivative. You know what, let me just copy it over again. Copy, go on. I put the derivative in for the derivative. And I put an a in there. And then for here, I just write the square root of a. Okay, so the reason why I have to pick a to be 9 is because when you look at this equation, if I plug 9 in there, I can solve it. I mean, I can find the square root of 9. It's 3. I can put the 9 in here. And the square root of 9 is 3. So this is 1/6. So this is another way of saying 1/6 of x minus 9 plus 3. Okay. And there's that's it right there, the green line. But I didn't need a calculator to do any of those things. There's no point in doing a local linear approximation if you're going to need a calculator to do any of those parts. So if you need a calculator to figure out what f of a is, then you've done something wrong. The only reason to use local linear is to make it easy on yourself to have nice, simple numbers. Because that's the whole point. It's an approximation to make things easier. All right. All right. That's the end of that topic. Everyone okay? If you're awake, do the thing where you raise your hand. Right? Can you raise your hand so I know you're alive? Hello? Because I'm going to start a new topic, and it's a very different topic than what I just did. All right, Kara put her video on, and she's waving a real hand. Woo! So have a Nana doesn't know how to do that. That's fine. I just want to make sure you're awake because I'm about to start something new. Mahir and Devon.
I'm here, Professor.
Okay, good. Anusha, are you here and awake?
Yes, I am. I'm just trying to figure out how to put my hand up.
No, that's okay. I don't care. As long as I know you're awake. All right, good. Everyone's awake. We're starting a new topic. It's a kind of, so that local linear thing, that's kind of easy. When you get an exam question, it'll probably be something like find the square root of 11 out. So that's what you'll do. This one's a little harder. Related rates is, so what you have is an equation that has functions in it. And you're not going to use explicit differentiation, you're going to use implicit differentiation, and you're going to take the derivative with respect to time. When you take the derivative with respect to time, you get all these derivatives with times in them, like dy dt, dx dt, whatever, and those are rates. Okay. And that's sort of what you're doing. You're trying to find how one rate relates to another. So let me give you an example. Let me give you a few examples that have to do with balloons. Did you ever blow up a balloon? And you're blowing up the balloon, and at first it gets big really fast. You blow it up and it goes, and like 3 breaths, it already looks like a balloon. And then when you try to make it bigger, it starts to slow down. Okay, these are rates. You're breathing at a certain rate, but the balloon is growing at a certain rate. And the rate of growth seems to slow down, even though you're putting in as much air as you did in the beginning. Or let's say you're using one of those tanks where the air blows in. You have a rate at which the air is blowing in, the volume is growing by a certain amount, but the radius of the balloon isn't growing as fast. Okay, and that's what they mean by a related rate. There's one rate is related to another. Okay. Another thing would be you could be raising the price of your goods. You could be a business person. You could be raising prices. You could be raising your price by $1 and $1 a day. That's a lot. But the sales will drop. So as you are raising the price by $1 a day, your sales are dropping by so much. Okay, so they're related to each other. The sales are related to the price. So the rate, when you're changing the rate of one thing, you're changing the rate of something else. Okay, so first thing you have to do is find the main idea in terms of a formula. Okay, so if it's price, if it's, you know, sales and price, or if it's the radius of the balloon and the volume of the balloon, just find the main idea. And then you just take the derivative with respect to time. When you take the derivative with respect to time, that will generate all the variables will turn into rates. Okay. And sometimes there will be other things involved, but we'll talk about that. And then you need to identify all the values and all the rates. And then you need to solve for your unknown. So let's start with what the rates and values look like. So rates, when you say the word that you need for rates is the word per. Remember that? Something per time, miles per hour. Those, anything with the word per in it is a rate. And when you write that, you're going to write it like dy, dt, df, dt, dr, dt, whatever it is. Okay, whatever if you're doing feet per second, that could be df, dt. If you're doing miles per hour, that could be dm, dt, or dy, dt, whatever it is. Revenue per day, that would be dr, dt. Those are all rates, and you could identify rates. T is which T in itself is just a variable. If you have any letter by itself, that's not a rate. Like the rate, it says something like the radius is, or the distance is, those are values. Okay. So the problem could have a main idea. Okay, so you're looking for a function like the Pythagorean theorem, x squared plus y squared, or the area equals length times width. These are sort of main ideas that you'll find. Okay, so let's see if we have an example. All right, so here's an example. They say, suppose the average yearly cost per item of production is given by this equation. Okay, and I just rewrote it as 14 plus 231x to the negative 1. Okay, so that's the equation right there. And then they say, if the current production is x equals 9, is that a rate or a value, x equals 9? Rate or a value? Anyone? There's no, I don't hear any time in it. It just looks like a value. X is equal to 9. It's a value. Okay. The production is increasing by a rate of 3 items per year. Does that sound like a rate or a value?
Rate.
Thank you, Nana. It's a rate. It has the word per in it. 3 items per year. X is the number of items. This is the number of items per year. So what they're giving you, so x equals 9 is given. And the rate is, since it's x that's changing, it's the number of items per time. dx dt is how you would write that rate, and you would write it as 3. Those are the two things that are given to you. And you have the main idea. Okay, now you take the derivative of the main idea. And the derivative of 14 is 0, so we throw that away. What's the derivative of 243x to the negative 1? Okay, oh, it's over here. dc dt is equal to minus 243x to the negative 2. What rule is that? What's that rule called when you bring the power down? You bring the number down, you subtract the power. What's the rule?
Dirty rules.
It's a quick and dirty rule, but this is a specific one that begins with a P. Which rule? Power rule.
Oh,
What did you say, Nana?
Power.
Power rule. Thank you. And then, since the variables don't match, we used another rule that begins with a C. Yes, anybody? It rhymes with what I'm in right now. because of my back.
Is it the chain?
It's the chain rule, Kara. Thank you. The chain rule. So to bring the power down and you leave the inside alone, right? And then you take the derivative of the inside dx dt. If you don't do that, you won't have a dx dt. You won't have any place to put the 3. So now you took the main idea that they gave you right up here, bloop, main idea. Let me make it a little bigger. You have the main idea, you took the derivative with respect to time, and when you did that, it became a power rule and then a chain rule. And you left the x alone, and then you took the derivative of the x with respect to t. Then since x is 9 is given, you're going to put a 9 in there. Okay, and dx dt is going to go in there for 3. Okay, so you're going to get minus 243 times, what's that? 9 to the negative 2. That would be 1 over 81 times 3. Okay, and so the answer is 9, whatever it is, costs per year. Okay. All right. I'm not going to do this one. It's harder. The relationship. So you have a baseball player, and the related rates are kind of interesting. Ow. Oh, maybe I should let you do your group work now before my back is. Apparently my painkillers kept wearing off. Okay. You have a relationship. We have the player and the ball's going across the plate. X is the distance the ball is traveling. 2 is how far the baseball player is from the plate, and theta is the angle between the baseball players watching the ball go by. So you have to remember your SOHCAHTOA, and you have to remember that that's x is opposite and 2 is adjacent. So you use TOA, and you have the tangent, and then you take the derivative. You see in red, I take the derivative with respect to time of the tangent of theta, and you get secant squared theta d theta dt. Okay, and take the derivative of x over 2, the x goes away, and you just get dx dt. And dx dt is how fast the ball is moving. And theta, they tell you theta, they tell you when x is 0, they want to know how fast the ball is going by, or how fast the eyes are moving. If x is 0, then theta must be 0 also, because there's no angle. When x is 0, it's right over the plate. The distance between the ball and the plate is 0. So theta is 0. So you plug in 0. If it was some other number, you would just plug that number in and use the Pythagorean. Oh, you'd use the tangent to figure out what that theta is. All right. That's all I want to say. This one's worse. So I'm not even going to talk about this one. It's horrible. There's so much. This is wordy and painful. This one is frequently on tests. This one I'll discuss. Okay, you have 2 cars. There's a police car and there's this red car. And the red car is north. It says the car is traveling 65 kilometers per hour. It's is traveling due south. So it's north and it's going 65 kilometers per hour, and it's 4/5 of a kilometer north of that intersection right there. Police car is traveling 49 kilometers per hour, and it's west. It's traveling west, but it's 2/5 east of the same direction. If the cop does a radar gun with the car, how fast is the distance between them changing? Okay. So the relationship, the main idea is x squared plus y squared is z squared. That's the Pythagorean theorem. Okay, then you see in red, I took the derivative of each one of those with respect to time. And when I do the derivative of x squared, I get 2x. That's the power rule. And then the chain rule gives me the dx dt. And then I have 2y dy dt, 2z. They're all the same. Okay. In this relationship, I have 6 unknowns. I have x, I have y, I have z, I have dx dt, dy dt, dz dt. Okay. They've given you 65 kilometers per hour. Is that a rate or a value? 65. Is that a rate or a value? Anybody? 65 kilometers per hour. Rate or value?
Rate.
Thank you, and it's a rate. 4/5, is that a rate or value?
The value.
It's a value. Okay. So since I'm calling y dt, then I have the police car. He's doing a rate of 49. That's the x dt, and 2/5 is his x. So I have all of these variables covered. I'm looking for how fast the distance between them is changing. So am I looking for z, which is a value, or dz dt, which is a rate? Am I looking for a rate, or am I looking for a value? How fast the cars are changing. What am I looking for? Z or dz dt? Anybody? Before I call on somebody. Jacob, am I looking? Oh, Nana's going to tell me. Go ahead, Nana, say it.
The rate.
I'm looking for a rate.
Yes.
Okay, so I'm looking for that. I have all of these. There's one that's missing though, Z. Okay, how do I find Z, the distance between these cars? Well, I know what X is, that's 2/5. I know what Y is, that's 4/5. So I can just use the main formula to find Z. I just use the Pythagorean theorem. Okay. All right. So then I just plug all those things in so I can figure out what Z is. Let me do it in Desmos. What the heck? Hold on. This one I'll put here. And this one I will put there. Okay, so let's see what we got here. So a new Desmos. Let's just take a new Desmos. Okay. So I have x squared plus y squared. Don't worry, I'm not going to do all of these things. So this was the original equation. And from that, I got 2x dx dt plus 2y dy dt. Oops. That's what happens when you don't look. Plus 2y dy dt equals 2z dz dt. Okay. And I just plug in the numbers that I have. I can plug in 65 for x. And then dx dt was 4/5. Oops, that's 3/5. And then I could do the same thing here, 49. And 2/5. And by the way, I've screwed them up, the x, so I said it doesn't matter. And then for the z, I put in the square root of 2/5 squared plus 4/5 squared. Okay, so that's my equation. Everything's in there except I'm looking for dz dt. So if I'm looking for dz dt, if I want Desmos to solve for it, I'll just put an x in. And now it should find the answer. The answer is that one right there, 80 miles per hour. So the difference between them is changing by 80 miles an hour. So one's going 65 and the other one's going 49. Okay. If they were going away from each other, you would just add the 65 and the 49. If they're going towards each other, you would subtract that. That's how fast they're going. Okay, that's the distance this way. But since one's going down, the other one's going straight, it turns out to be 80. So anyway, any questions on that? Let me make this bigger. Sorry. All right. All right, that's standard related rates. Related rates look an awful lot like other types of problems. But I tend to, this is the one you see the most, is this car problem. That's the one and most of the time people just memorize the formula. Let me just say, the formula that most people memorize when they're doing this is, back here for a second. They take this to the other side. Okay. So the formula looks, and they're all the twos are gone. You don't need any twos. So that's the formula that I see students put on their tests, and I'm okay with that. Okay, in other words, you multiply the first two numbers they give you together, you add the first two numbers they give you, the second sets of numbers together, and you divide by the square root of the fraction squared. Okay, the value squared. That's what this formula is that people use. Okay. All right. Oh yeah, we done with that? I have some good test taking advice in these notes, but I'm just not going to do it because I don't feel like it. So let's break up into our groups for now. If you want, I'll give you some more test taking advice afterwards, or next time. But let's break up into our groups. We have two groups, right? That's easy. You're all on black. You're all here on Desmos. Not Desmos, on Zoom. Okay. Let me just very quickly tell you what you're going to do for mean value theorem if you don't already remember, because you might have forgotten what the mean value theorem is. Did anyone post for the mean value theorem? No. Okay, so here's the mean value theorem. What you do is you're going to go down to the mean value. You have your data in and whatever, you're going to go down to the mean value theorem. You're going to open it up. Okay, you can turn on this right here gives you the average rate of change between A and B. So people need to know what A and B are. If you want to move them down, that's fine. So you could move the A and B down in your worksheet so the producer can show them. That would be nice. What happened to my A? Go in here. Yeah, there it is. Went in there. So it's not necessarily that easy to move the A and B. But here, I'll put the A and B there so you know that I'm talking about between 0 and 20. The average rate of change is 50. Okay, if I do this, I can see that, you see that orange line? That's the secant, secant line between 0 and 20. Okay. The blue line, I'm just gonna, so I turn the blue line on, I turn the derivative on, I find the intersections. The intersections, there's few intersections here. So those are my three values, minus 1.2, 7.5, and 17.48. The one that I want are 7.53 and the 17.48. You only want the ones that are between your A and B. So this is what I want the producer to show. I don't need to see these, turn them off. But I do need to see this. So go down to this thing and put on the tangent line. You have to put in one of your answers, either 7.53 or 17.48. So that's what 17.5. So a producer should have something that looks like this. I should see the average rate of change and the instantaneous rate of change. I need to see that they're the same values. Okay, they're all 50, and I need to see this picture of them and they're nice and parallel. Okay, if I want to use the other one, 17.486. See, I have another, now I have a different parallel line. You see how this tangent line here is parallel to that orange line? Okay, and the other one, that one was also parallel to the orange line. Okay, so either one, as a producer, pick one. Okay, but that's what I'd like to see as a picture. I want you to show me average rate of change in orange. Rate is 1.266 minus 1.266. It's parallel. Okay, but the point where they intersect is here. That's
Where
not.
did you get those numbers again?
Okay, so so things that I made go away. I made these go away. I turned them on, and then I found the numbers, and then I turned them off. So I found the numbers where the blue line, which is the average rate of change, is equal to the derivative. That's the instantaneous rate of change. See, all I'm saying is find the derivative. And then I'm looking for when they're equal to each other, and these are those points. So I click on the intersections of those two. Okay? So that's what you're going to do first. Before you do anything, turn on the blue line, turn on line 96, turn on line 97, find those intersections. Determine which ones you keep. We're not keeping that one. We're just keeping these two. Okay, write them down, or put, if you want, just start, you can make f prime of those two numbers because that's what you're going to need. Okay?
Okay.
All right, now here's the problem. You have a big group. One of your groups is big. The small group is going to have any problems. The big group is going to have a problem. So you may have to, if you may, as a producer, you may have to choose a different, change it to a different, change these numbers to something else, like between 6 and, I don't know, 26. So if I do 6 and 26, there's the secant line there. And then I do find the intersection. By the way, if you notice when I do 6 and 26, there's only one intersection, and that's right here at 19.77. So the producer might have to do this twice with different numbers, unless you can find things for other people to do. Okay? And the things that are said, the writer, all the writer has to write is that the average rate of change is equal to the derivative. Okay? So average rate of change equals instantaneous rate of change. And then try to put the units in because those are rates. Speaker saying according to the Cordic regression, the average rate of change between 0 and 20 hours is equal to the instantaneous rate of change at 7.5 hours and 17.5 hours. Okay, so you're just saying flat out the average rate of change is equal to the instantaneous rate of change at those two times, whatever the X values are. So if you're doing studying for grade, your average rate of change between 0 and 20 hours of studying will be equal to the instantaneous rate of change at whatever, 7 hours. Okay? All right, let's break up into our groups. Does everyone remember what group? In business people in group 1 and everyone else is in group 2? Yes? Who are my
Yeah.
business people? Mahir is in your group, and Sarah? Okay. Okay, so you guys are in room 1.
I'm also in business.
Who just said that? I'm sorry, I missed you.
Suhavi.
Oh, so
I'm in the business group too.
Anusha? Shh.
Yeah.
Okay, everyone else? Christian, oh, Christian doesn't go in a group, neither Nana, Nyla, Melanie. guys are all in 2.
Professor,
Yes.
I'm in the other group. You sent me with the business people.
Sarah, you're in 2.
Yeah.
Yeah.
Okay, there you go.
And then do I have to make the purple line parallel to the orange one?
No, the purple line is the purple line show the purple line. So when I do the purple line here, I turn it on. It's got to be something like for this group, for this one, it's like there. You see that?
Yeah.
Turn off the blue and the green, it'll just confuse you. Just see the purple line it's at 20. It's the number that you find, whatever the number you find, but it should look like that. I need to see it parallel. I just did this by moving it around, like there, 19.5. Okay, that's what I want to see as a producer. I want to see that, and I need to see that the average rate of change here, which is 97.28, is going to be the same as, what is it, 19 point? 19.9 maybe? Hold on, 19.9, is that better? Yeah, it's 19.8 or something, but you see, I need for this average rate of change, 97.28, to be the same as the instantaneous rate of change. And the way I got that was, again, I turned these on. Let me get the right answer here. 19.77877. 19.77877. See how they're the same now? And that's
Yeah.
what I should put in here, 19. Copy. I should just put that in here. Can't tell the difference on that one, but turn these off. Once you have them, you don't need them again. Okay. You can, yeah. All right, so that's what I want to see. I want to see the A value, the B value, the average rate of change, instantaneous rate of change. I want to see that the derivative at the point you found is equal to the same as the average rate of change. And then I want to see a picture of it like that. And the way you get that picture is by turning these on. I don't need to see them, and I don't need, these don't have to be on. You can turn them off. Okay. All right, any other questions? Go join them. Who am I talking to, Devon? Go join your group. They need you. You're the producer. They're probably just chatting away. Christian, you okay? You want to join one of those groups? You're welcome to.
Yes, I'll join. Thank you.
Okay. I'm gonna go join group 1 first. Stop and join. Okay, sure.
Yes, sir.
Wait, I think he ended it. Right?
Do we
I
have
thought he was gonna.
or
I thought he was
do we
gonna
leave?
go. No, there's 7 people in the other breakout room, so he's still
Yeah, I
here.
just looked. I think he's over there. But you can just like wait here, I guess.
Do we have to stay though? It's like 5:30.
I think he's gonna review some stuff about the test, so I guess if you want to say you can, but I don't think he'll really care if you leave.
Don't we have class on Thursday?
Yeah, but he said he's gonna go over some stuff. I don't know.
Have a great day, guys.
Wait, are we sure that it's just like wait, who are the 3 people in the first room?
Um, in the first room?
I feel like it's just like glitching out and he actually left.
No, yeah, no, it says that that's where we're supposed to be, but it says not joined.
Oh, okay.
Yeah.
Oh, but okay, I see him and okay. Wait, I'm just gonna leave because I literally have to go. So if he asks,
Okay.
just like tell him that I have to leave.
Okay. Okay, that's fine.
You okay? Why are you out here? Nobody's out here. Good. Let me just.
Professor, I have work and class has been over for 10, like about 10 minutes, so I'm gonna go.
Sarah, are you talking to me?
Yeah, I'm just letting you know that I have to go and class is over.
Okay, go. You can go. I don't know what else I'm doing between now and then, but right now I'm stretching my back.
Okay, feel better.
Oh, thanks. I'll talk to you on Thursday. Oh, hey, Sarah, one other thing. Are you there?
Yeah.
I haven't decided yet if I'm opening up. I have the option to open up some assignments that I've made in the past that might be helpful. I just don't know if I'm going to do it or not, but I probably will. So look for it. In other words, don't have a. I do have a practice test, but I don't like the practice test. It's not as helpful. But because this test is in itself a practice test, but what I do have is all the quiz questions and an assignment. So that I might post, but I haven't decided yet. So keep an eye out for it. Okay.
Thank you.
All right. Talk to you later. Bye bye. Did this class end? This class ended. What the hell? Hello? Suhave?
Hi, sorry. I didn't know if you were gonna meet with us again.
No, I'm not,
I
because class is over and I forgot about that. So
oh,
we're
okay.
done.
Sorry.
Okay.
Bye. Hope
I'll
you
see you
feel